right, and I'll share my screen now. Cool. So we are not going to run through the board today just because we have so many other things to worry about for launching mainnet, and we kind of already know what has to be done. So let's go ahead and just do the testnet check-in and discussion. What's the status of testnet? I think everything is working, right? Like there's no real issues besides Ludo's issue and my upcoming PRs.
Yeah, I'm not aware of any infrastructure issues, no restarts.
That's what I like to hear, especially before launch. All right, discussion. I have 1805 listed here, but I want to hear more about Ludo's issue first, since that seems to be a fresher one.
Yeah. So the issue is in the stacks node. And so, yeah, it's something that we didn't see in the past because, yeah, the Bitcoin blocks were being produced like the setup on Rectest was really predictable, and with mainnet it's a bit different, and also testnet. So basically, the issue is when you submit a transaction, like a leader block commit, if you received a new Bitcoin block that doesn't include that transaction, the node will be stuck on trying to submit a new operation, because the setup that we have right now is like you just have one UTXO, and so the UTXO that you have is already being used for the previous block. Mm-hmm. So the node is basically looping on trying to submit a transaction, and it's getting like a no UTXO error.
So if the block commits late, it's using stale UTXOs because it still thinks it's waiting for that.
No, it's not getting any UTXO because the only UTXO that the account has is already being used in the previous block.
Right. It doesn't, but if the node just refreshed its UTXOs for every new Bitcoin block, would that fix the issue?
How do you perform this operation? Is it like something that is it an operation that you do on the Bitcoin?
No. So I mean the Bitcoin controller, it keeps its UTXOs around for the duration of a Bitcoin block in case it needs to do a replace by fee.
But I think that in this case, the stack node is trying to fetch new UTXOs, and it's not getting one. Like, do you know if a Bitcoin node would return you a UTXO that is currently in the mempool, like, that is being used for a transaction in a mempool?
I don't know.
I don't think that would be the case, no.
Yeah.
I haven't seen that behavior though. I mean, so sometimes you just the node is just skipping blocks.
So if you look in your logs for failing to submit transaction, you should see like a bunch of. It happened to me locally. It also happened to Dworker, and I saw it on mainnet. Like it's yeah.
Do you have the exact spelling of the message so I can do a grep of the log, because the log is getting a bit big.
Yeah. I can send you guys something because I've definitely seen that happen a handful of times.
Because I've seen other things that we could talk about, but that's not one I've noticed. Although I'm not looking directly at the log, the file is too unwieldy. Just grepping for things that I'm hoping to find or not hoping to find.
Yeah, so the problem is that we broadcast a leader block commit. That UTXO is like in the mempool, and then if we want to submit another leader block commit, the miner tries to double spend. Is that the
Oh,
issue?
yeah.
with
If it
it?
doesn't use the same UTXO set for each, yeah, the node will reject the transaction instead of replaced by fiat.
But in this case, the Stuxnet is not able to like get a UTXO from the RPC call to the Bitcoin D node.
Oh, because the Bitcoin D node isn't returning unconfirmed
Yeah.
UTXOs.
Oh, yeah, I see.
Well, yeah, so you can pass an unsafe equals 1 flag to Bitcoin D to return unsafe UTXOs. And these are unsafe UTXOs.
Okay. But
So
is it something that we want to do, or like because I feel like this is something we could avoid if I had like 2 UTXOs in my account, like that would be a non-issue. Like, this scenario would be a non-issue. So maybe yeah,
it would sort of be, yeah.
But you would be breaking the TX chaining, right?
Yeah, I mean, the ideal situation for a miner would be to actually just replace by fee.
Yeah.
Because like they know that that block commit
Yeah, it's not going to make it.
is not going to yield a block.
Yeah. So okay.
But I'm inclined to say that like we should not be trying to deal with that issue before launch, just because, yeah, I think that managing miner UTXOs is actually pretty complex, and maybe different miners are going to have different policies. One thing that we do probably need to address is the issue you were talking about before, which is the TX fee setting.
Oh, okay. So for that, yes. So okay, is the issue clear for everyone? Yeah, it's basically, so yesterday I was trying to just register a key, and yeah, my transaction has been pending in the mempool for 10 blocks.
Yikes.
And yeah, right now we don't have the ability to increase the number of satoshis per virtual byte. Yeah. So I think that a quick like a quick and dirty trick that we could use here is like if we can maybe dump the transaction in the logs, miners can get that transaction and submit it. No, yeah, I don't know. No, actually, it's
I see.
Yeah, I don't know. Actually,
I think like what we should probably do is pull this TX fee from some kind of API. So we can either like we can add a config setting for like the API for getting current Bitcoin transaction fees. And I know that we run a service for like the old Stacks wallet that returns Bitcoin fees. And then there's also like earn.com. There's a bunch of services that will just tell you what the best TX fee to use is. So that's like one potential way to solve one potential part of this problem. The other potential part of this problem is the estimation of the bytes might not be accurate.
Yeah.
Like, yeah, if we're setting the Satoshi, like if we're setting 1 sat per virtual byte, like, is the actual setting of the TX fee being accurate? Like, because it has to do some like prediction based on the number of UTXO inputs and stuff like that.
Most of our transactions are fairly predictable because
yeah, I mean,
the leader block commit, depending if it's a burn outside, like in the prepare, is slightly smaller than because it's only 1 output, other versus 2 outputs. The leader key is the registration key is also always the same size. We could even hard code the value and not even try to guess from what we're building.
Yeah, I agree that our transaction format is super predictable. So like this should be doable. It's just a question of whether or not we're currently doing it. So
No, we're not. We're just always using 5500 for now. Or there's a
I see.
there's a config value we're using, but that's not.
Yeah.
That would be
different, right?
slightly over. I mean, we could always put the more. The miners won't mind.
Won't complain. Yeah.
And sometimes from what I noticed, the service fees, like the earn.com values, is probably overkill in many cases. But
Yeah.
but it's definitely safe.
Right.
'Cause,
Can you just use the estimate fee API in Bitcoin? Like we're already talking to the Bitcoin node already.
well, you need to keep track of what's in the mempool and what gets in and what doesn't get in. That's a whole different thing that Bitcoin D doesn't give you. There are other services or servers that you can put on top of Bitcoin that index all the mempool and the transactions, but I don't think we want to necessarily get into that. So for now, just using whatever API, and people maybe can put a factor on it, like put 90% of that value or something like this. But then if you get too tight, you're not going to get in the next block, and then your commit is pretty much useless. Although you could have some logic. If you figure that out, you could replace the transaction with a new commit, but then you miss the block, and you get the smoothing is going to get you anyway. So missing a block is not really an option for mining, I think.
It's not quite that dire. Like if you miss one block, you're if your UTXO chain gets interrupted, there is some leniency to it. It's just that leniency is capped at the modulus constant, which I think is 6, right?
Yeah, but you lose some of the weight of your
You do lose
of your commit or whatever burn or POX. So if you do that once in a while, that's fine. If you do it all the time, then that your efficiency is really going to get affected.
Okay, so the just trying to summarize here, like the problem here is that our leader block commits and our leader key registers are getting delayed just because we have bad or absent fee estimation in the Stacks miner code.
Yeah,
Correct.
On mainnet, on testnet, that's been fine. But...
Yeah, I mean on testnet it's way more lenient, but on mainnet.
Oh yeah, on testnet you see transaction with one Satoshi per byte. Our average is about 15 or 16.
Comparatively speaking, that's empty. Okay, so the how hard is it how hard do you think it would be, like t-shirt size wise, to graft in just a query to a fee estimator? Like say earn.bitcoin.earn.com or something.
I mean, I would say we should, what we ship with, we should maybe make it configurable, but I think plugging in an external API at this point, if that's something that other miners, want to make modifications, that's fine. But I don't know if we should spend a lot of time on that.
Well, I understand, and I'm hesitant to do this as well because I don't like the idea of our node being
right. Yeah, and the value returned by earn.com has been stable for weeks, but it's been higher before it got to 102. Currently, it's 102, and it's been like this for weeks.
Do you think we could use the fee estimator that we currently, we being PBC, not me specifically? I mean, I don't work at PBC, but PBC maintains.
Yeah, we could. I mean, that estimator is just taking earn.com and multiplying it by 1.3.
Great, sounds good.
But I think that the point that Doakro was making is that trying to do this dynamically by continuously querying a TXV endpoint is maybe not worthwhile right now, especially because fees have been so stable. Like fees have been at like 110 for like 2 months. Like if the config setting, if a miner just set a config setting for Satoshis per VB, like they would be mostly fine. The painful thing is like restarting our nodes requires resyncing the whole blockchain, but like, I don't know. Like,
I mean, we could, so one guidance we could provide to miners is, if they wanted to, let's say bump up their fee, they could spin up a separate instance, with the same miner key, let that catch up. Once it's caught up, they can terminate the first instance.
Well, this is a separate problem. Like the ability to stop the node and restart it without worrying about corruption is a long-standing issue. And once we get that fixed, then this is immaterial. Like you just stop the node, or better yet, what if we implement a SIG user one handler? Like most Unix software does this. You send SIG user one, it's a hint to reload the config.
Yeah.
Mhm.
Yeah. So I think that the actually querying the API is like not, I don't know, it's simultaneously not that important, but also not the most difficult part here. The most difficult part here is actually estimating the transaction size before outputting it.
Well, the main one is 352. That's two outputs.
Why is this hard to estimate? Just serialize the transaction with the flat fee and then use the bytes there, the byte length there, and then reserialize the transaction again.
You can even hard code it. It hasn't changed in a long time. It's just we introduced a change with the prepare thing that does only one output, which is slightly smaller. But even you get the Explorer, you get the value, and you hard code it.
Well,
you had a flag that says it's one output, two outputs.
Pascal, we're talking about a few different things here. Like, yes, the value is stable, but it's not going to be stable forever. So hard coding it is basically a non-option. We could put it in a config file, but as Walker points out, the act of making that config file take effect is tantamount to restarting your node from Genesis, and that's also a non-option. Trying to make it so that we query a service is also undesirable for other reasons. So it seems to me like the best solution here is going to be try to find a way to make it so that you can take a TX fee from an external environment somehow, but without restarting the node. And then we leave it to the miners to figure out.
I'm sorry. I don't know. I disagree. Like, okay. I think we just need to get something that is going to work for miners for the next week.
Yeah, no, exactly. Yeah. And if it's just hard coding the transaction fee, the V byte per V byte, the status fee per V byte in the configuration file, which is like a trivial change, that would work.
Yeah.
Yeah, we should do that. And then, sorry, go ahead, Pascal.
Even restarting during the Xenon phase, I restarted because I changed the configuration, and you just make a copy of the data directory, and you can always try to do it. If it doesn't fail right away, you're fine, and it worked.
Nice.
It still can be a crapshoot, and if the data is half baked, then yeah, it's going to fail. But that would be fine too. And especially what I had done is that I had a photo error, and I left it running. I just took a copy, so you can take a snapshot and try to restart nodes from the snapshots. Taking a copy while it's running, it's a little trickier, but that works. That's I've seen it fail, but I've seen it work as well. So there's plenty of options that miners a little crafty can use to not waste too many blocks.
Yeah. So adding Satoshis per VB to the config seems like a good compromise to me. And then based on kind of my read of the code, I actually think that the amount of work needed to make the node crash safe and for us to be able to restart from working there, it's not that much work. So I feel like after the mainnet launch is behind us, we could quickly fix that behavior. It's a non-consensus breaking change. And so I would, spend cycles there rather than try to do something very sophisticated in terms of like adding dynamic fees and so on, which, someone is motivated enough, they can always do that themselves. So I would just, we've spent quite a bit of time on this issue, so we should probably pick a path and move on.
I wrote down the 3 action items there. Does that all look good to people?
Yeah, I'm just concerned by the fact that the first issue that I write is ending up being a non-issue. Like, for instance, like my node on testnet, like it's a blocking issue. Like I have a node running on testnet and it's stuck in this loop.
Is
And
this the same as the?
It's been 4 hours now. So yeah. If
Is this the same thing that my node was running into, Ludo?
Yeah. So I think that we should at least write a patch that maybe exit the nodes, or I don't know, but like running the node for, like keeping the node in this loop is not a good approach, I think.
I haven't seen that happen to mine, but if it happens to one, then it's going to happen to others. Just a
Wait,
matter of-
Pascal, you said that you see those messages in your logs as well, right? The failed to submit.
Yeah, I've got a few hundreds. I was looking at some other things the past couple days about forks, but I didn't start looking at Bitcoin transactions yet for what I was looking at, but I was going to look into it. Because I see things that change, because I see that run tenure, sometimes it's being run 20 times, and maybe that's because of this. At least the log says it's starting the run tenure on the same block. The varying number of times. I don't recall seeing that before.
Yeah, I think that that's a different issue. I think that that's from.
Yeah, I'm not
the
saying that's necessarily an
microblock
issue. It's
mining,
just.
But yeah, it's just attempting to mine microblocks.
Yeah,
and
but
stuff. Like that's.
It seems surprising to me they would do that, but I don't think that's the cause of the fork. I've got other issues that definitely are more concerning that we can talk about if you want. But.
So Ludo, I think that the issue you're discussing, that the miner node gets stuck if its UTXO is its only UTXO is like permanently pending. I don't know, like the way to solve that problem for miners is to try to replace that transaction by fee. And I think that will add so much complexity to the Neon node that I don't think we should be trying to achieve that
but
right
actually,
now.
okay. But thinking more about it, maybe like the sats per VB solution could also solve that problem, right?
Yeah. So like by setting the sats per VB, just like setting a higher TX fee for all these transactions, like hopefully this problem would be avoided or at least minimized, right?
Yeah, makes
like
sense.
if your transaction has like 120 sats per VB, even if it's not included in the next block, it'll be included in the block after that. Like you're not going to be waiting 4 hours.
Okay.
And yeah, so.
Cool.
All right. And then we can also, I mean, add some guidance or discuss in the mining channel. Like if someone does run into this problem, there are a handful of things that they could do, right? They could try to send another UTXO. They could try to restart their node. So we could just try to address it, remediate it through documentation. Again, the hope is that, once we get to a point where, Pascal's PR is making progress, the hope is that people will build on sort of much more sophisticated miners with different strategies, so that, the core node shouldn't have to worry about it. So it seems like a good path forward for now.
Yeah, just one question. Are we expecting, like, do we think that, I know that the Daemon fund, like the Daemon company is working on a miner. Do we think that the miner will be using like the Daemon stuff, or like, what's the?
Not sure I follow your question, Ludo, but basically the way my understanding of Daemon's mining bot is that they essentially just pull in the latest Stacks blockchain repo, and then just build in mostly like a web interface on top of that. So
I think Zen want to be able to use my PR, but my PR is not quite ready for prime time. And Especially I tried with Xenon and something doesn't, after many rebases, something doesn't work anymore. So I need to try to figure out what the problem is. I think it's the modulus that got added that I'm not feeling right. But so I'm discussing with Zan probably later today about how to move forward with that. But I think initially they're going to use the regular node for now.
Yeah.
Okay, so
Does that answer your question, Ludo?
Yes.
Okay.
cool. So we can add the VB sats per VB to the config file, hard code to whatever default value is sensible for now, and then we'll worry about crash safety and possibly RVF after doing that.
So is Ludo, are you going to do that, or is that something I should do?
I have bandwidth for taking care of this, I think.
Okay, anything else on this issue? All right.
Yes.
Guess not. I'm happy to talk about what the status of 1805 is. I hope to get a PR out by the end of today, and I know it's been kind of long coming, so I can give you a high-level description of what's to come if you'd like.
Yeah, I would appreciate an update.
Sure. So there's two concerns fundamentally when a node is on the Stacks network that it has to be aware of in the face of dealing with POX reorgs. The first concern, and the concern that issue 1805 mainly talks about, is what happens if there is a hidden anchor block and a long time later, like several reward cycles later, someone releases that anchor block. How do nodes know to, when is it appropriate to process that anchor block is the main question here. And the consensus from the 1805 issue discussion is that it's only appropriate to process that anchor block if the best Stacks chain has built on it. This solves the problem of having to worry about a short-lived attack that produces a hidden anchor block, but then the rest of the network overwhelms that attacker later and builds a proof of burn chain through that reward cycle, and then it resumes doing POX afterwards. I've worked out a way to, and I've written it up in that GitHub gist of how to calculate when this happens, so that the only way that hidden anchor block will ever be accepted into the canonical Stacks chain history is if the majority of the network has affirmed it. So they've built subsequent reward cycles that build on that hidden anchor block. And we can measure this by looking at the prepare phases of subsequent anchor blocks, subsequent reward cycles, and see and deduce from there whether or not the those prepare phases have descended from that hidden anchor block. And we don't have to worry about them looking at a particular Stacks chain. We just need to deduce whether or not the network has effectively voted for a chain that descends, any chain that descends from it. So that's the first issue, how to, like, making it so that the only way a hidden anchor block can ever be accepted into the Stacks chain is if there's subsequent evidence that the network has built upon it. That is important also that's important for currently running nodes. So if it's the case that a hidden anchor block is mined, but the rest of the network has not affirmed it in their subsequent reward cycle prepare phases, then that block knows to reject it. It knows to just pretend it didn't see it because the rest of the network hasn't built on it. And therefore, it can deduce that this is an attacker hidden anchor block and no reorg will happen. So that's the first piece of 1805. Dealing with late arriving anchor blocks. The second piece of 1805, and this is something that I think we were bitten by recently, is what happens if none of your peers have an anchor block that actually is built upon by the network. You have to be able to do a few things. You have to be able to tell, first of all, without having even processed any Stacks blocks, is this reward cycle expecting an anchor block? And if so, how does that affect my chain synchronization? Like as I'm booting up, I have to be able to either just ignore this anchor block because I know it's never going to arrive. The rest of the network hasn't built on it. Or I need to wait. I need to start finding neighbors that have this anchor block because I know it exists. The rest of the network has affirmed it, and therefore I should kick out any neighbors that don't have it and keep searching for neighbors that do have it and only proceed to bootstrap once I've found such neighbors. Otherwise, you find yourself in a situation where your node waits, for the timeout that we have. It keeps processing as if the anchor block isn't there, and then it gets stuck because later on that anchor block will arrive and it will have to go reorg itself, and it will have to do a quadratic amount of work at least in reprocessing all of the blocks with that new anchor block present. And that's what caused like the Xenon node, for example, to take forever and a day to go reprocess itself, because it just it kept missing anchor blocks that actually existed. Making these things happen, though, requires two separate code paths. To make it so that you deal with late arriving anchor blocks, we calculate a structure described in that gist called an affirmation map. And that's just an ever-growing list of decisions that the prepare phases of each reward cycle has made. An affirmation map has one of three states in each. So an affirmation map has length equal to the number of reward cycles, and the ith entry in the affirmation map is either no anchor block in this reward cycle, there is an anchor block and the network built on it, or there is an anchor block and no one built on it. So there is a way to, describe in the gist, there is a way to calculate the heaviest affirmation map, the one that the network has confirmed the most. Once you have that, that gives you the needed hint to determine whether or not an arriving stacks block A is an anchor block and B should be ignored, because its affirmation map entry for that reward cycle we marked as anchor block exists but not present. So that in that effect, that all's working. That all happens inside the sortition logic. We calculate the heaviest affirmation map as we process sortitions. The other half of this lives inside the burn database, because before we can even start processing blocks, we have to scan through the block commits. We have to look at the block commits that correspond to prepare phases. We have to calculate the sortitions for those blocks, and then we have to deduce the estimated heaviest affirmation map, so we can then determine which of our nodes, as we're bootstrapping, is on the same page as us with the heaviest affirmation map. So if I notice that all my peers, for example, don't have a anchor block that my estimated affirmation map says must exist, then I kick them out.
Does this work with prefixes of the affirmation map?
Yes.
So if there's a node in the network, node B, and they've seen whatever, the first 15 reward cycles, but I'm on I've seen processed the first 30.
Oh, I see what you mean. The no. You have to process all of the affirmation. You have to process all of the block commits and prepare phase sortitions before you can begin downloading blocks.
And that's true of the other nodes as well.
Yes.
I see.
Because once you have the estimated affirmation map, then you can proceed to identify which nodes, given their POX bit vectors, are consistent or inconsistent with it.
I see.
So like as a node, what I would do if there are 30 reward cycles, I would boot up, I would download the Bitcoin headers as usual. I would download the Bitcoin blocks as usual, extracting the leader key registers and the leader block commits. And then what I would do is I would scan through all of those block commits. I'd pull out the ones that correspond to the prepare phases. I would calculate the sortitions for them, and I would deduce the estimated affirmation map based on what block commits each of the prepare phases had confirmed. So there is a chance, this is a heuristic, you have to understand, there's a chance that the estimated affirmation map will be wrong, but it is going to be right if the majority of the network is honest most of the time.
Right. But I think like the issue that we were facing in Xenon 3, I think, and to a certain extent in Xenon 4, is just basically block propagation wasn't happening fast enough. And I would say that in Xenon 4 in particular, it had very little to do with POX anchor blocks.
Well, right, and this is actually the kind of the crux of the problem here. The reason that block propagation is going slowly is because the propagation doesn't happen until you've done an inventory synchronization. But in order to do an inventory synchronization and also avoid this problem where your neighbors might not have an anchor block that is affirmed by the network, you have to synchronize with everybody all the time to find the one of them or the handful of them that are the ones that have the anchor block.
I see.
And that gets slow if there's lots of nodes. And the reason why the pruning PR I have isn't good enough is because the pruning node needs to only prune neighbors that it knows don't have the anchor block. Otherwise it'll partition itself off from the network and it will never find the anchor block.
I see.
So Jude, where are you in this PR in terms of implementation versus tests? Kind of what's the status of, yeah.
So I mentioned these three pieces together, the calculating the affirmation map, calculating the estimated affirmation map, and doing the pruning based on the affirmation map. So I have the code that calculates the affirmation map is working. The code that calculates the estimated affirmation map is almost working. I'm doing testing on that right now. The pruning part that maintains a certain number of maximum neighbors is working. That was what that PR sent. But the part that ties the decision of what neighbors to prune based on the estimated affirmation map is not written yet because it needs the estimated affirmation logic to work.
So at least kind of my interpretation of how these two things are connected is we need some heuristic to decide which nodes to prune, and the work for 1805 is going to be that heuristic. I guess the question is, depending on where we think we are with 1805 and how much longer will it take, like, is there another simpler heuristic we can use in the meantime to do the pruning?
I would love to know one if there is.
But
Anyone have ideas?
Isn't the pruning just to reduce the number of nodes because you have too many neighbors?
You have to specifically prune the ones that are not telling you the blocks that you need to know. Like if you just prune everybody, then you enter this pathological situation where the anchor block gets mined, but only a handful of nodes ever learn it because most nodes have pruned that one miner.
Yeah, and I would imagine we also want to keep some randomness in the pruning so that we don't lock ourselves into like one corner of the network forever.
Yeah, of course. Yeah, we definitely do that. The let me give you a better way to help frame this. Back in the Neon days, before POX was up and running, this already implicitly happened. Like you talk to a node, we don't consider POX at all. We just look at what blocks you have and what blocks you don't have. If you don't have blocks, like you're an unhealthy peer.
So I guess I have maybe two questions. So currently, in order to push a block to a peer, even if it's a block that I'm expecting in my sortition DB, you need to be in my peer table, right?
You'll have had to have connected, yeah.
Okay. Can we change that? Like if I'm expecting a block hash and somebody delivers the inverse of that block hash, I should just accept the block.
I agree.
That's already the case. Like there's outbound and inbound peers. If you're an inbound peer to me, like you're just some random node that's connected.
I'm talking like a pruned peer.
Right. So the pruning system that I've written only concerns itself with outbound peers. So if you just connect and send me a block and disconnect, that's fine.
Did we lose Aaron?
It's frozen.
Oh, maybe it's going back now.
Hey, Aaron.
Oh, he lost network. Oh, there we go.
Yeah, so I didn't.
It's been pruned.
I was pruned, yeah. Okay, so if a node is pruned, but they try to push block data, will that block data get accepted?
Yes. The pruning applies to the outbound peers, not the inbound peers.
Okay, then I think in that case, I'm not worried about this. Like, if everybody prunes their peers and we just have, I don't know, the seed nodes never get pruned, miners will always push their blocks to that seed node. And other nodes on the network are going to eventually get it. And like, I think in that case, we're like 98% of the time in sort of a happy path.
I agree. Like this PR 1805 and such, like if we ship it later, like after mainnet, it's going to be fine.
Right.
As long as everyone has the seed node in their peer set, then and everyone connects to it.
Yeah. But like that also depends on turning up the pruning. So like we need to be able to get the number of peers below 200, because without that, like the networking basically just doesn't work. And so
Yeah,
maybe a path forward is to do the pruning PR and evaluate 1805 separately, right?
Yeah, and that's what kind of what I was trying to get at. Like, if we can get to a point, like right now, the pathological scenario is you have so many nodes on the network that the inventory synchronization takes, I don't know, somewhere close to 10 minutes, and then we're kind of stuck in this situation where miners keep falling behind. I think in your PR, Jude, it's capping to 128 nodes. Do you have a sense of like at what number does that fraction like starts to edge close to 10 minutes? Because like, the immediately post launch, I don't know how many nodes we'll have, but I'd be surprised if we had, anywhere near 100 active miners or like several hundred nodes. So if we can just make sure that, the pruning is such that, it'll cap the number of peers to, I don't know, like 50, 60, some number there where we know for sure there is an upper bound on the inventory synchronization that is well below 10 minutes, then I think we can be fairly sure that the network will remain healthy while we can still work on 1805 in terms of just, limiting block propagation time.
I agree. It's the difficult part here is the when we spin up a new Xenon node with that PR applied, it's going to have to go and find all of those anchor blocks.
Yeah, but that's fine because it should be able to get them just from like the seed.
Yeah.
Right.
When we replace the seed. Oh, I see. So when we replace the seed, when we replace the miner is separate from the seed right now, right?
I think right now they're one and the same, but when we replace one, like, I don't know, we could leave a follower up. Like, we have two nodes in our infrastructure that presumably have the full chain state. And so you restart one while the other one lives, it'll be able to download the entire chain history from the other one.
In theory, yeah. You want to make sure that the other one is its seed node, so it's always in the peer set.
Yeah.
That's what I did an experiment like this in it was Krypton, where I had no, that was Xenon actually. I had a follower and I restarted a new node with that node as the seed because I knew it was like correctly synchronized, or at least as best as I could tell. And that worked because my new node was resynchronized very quickly. Still did it overnight because it wasn't, I had to go to bed before it was finished, but it looked like it was working fairly. So that seems to work. Although curiously, even the nodes being on the same machine, they were regularly 1 block or 2 blocks apart in terms of synchronization on a regular basis. One would get a block and the other one wouldn't get it till like several minutes later.
Probably when it woke up to go and resynchronize the inventories, it would notice that peer had a block and it would download it.
Could be, yeah. I don't know. I haven't actually compare the logs, but that was still interesting that they would not be synchronized very quickly. I was expecting them to be, but
Okay, so action item, can we make it so that when we spin up the new seed node for our system with this PR applied, it will have the follower as its seed node and vice versa?
Sure. I think that the other action item is to like merge whatever that PR was, the prune PR.
Yeah, I
Uh,
think we should merge the prune PR with, some number of capped feeders where the block propagation time would have a good bound. And then I think there's a separate question of, how to kind of architect the nodes that the foundation will be running, the nodes that PBC might be running, to make sure that we have sort of a good way to seed various nodes in the network. So we can tackle that separately.
Mhm.
And then maybe a related problem is currently does the config only admit one seed?
mhm.
I think the config does, but the API lets you have as many as you want.
Yeah. Okay. So maybe what we can do is enable multiple seeds in the config, because that'll also help with this setup.
Can I just put that in part of the merge PR?
In part of the pruning PR.
Yeah, sorry, the pruning.
Yeah.
PR.
Yeah.
Okay.
Regarding the seed, because you need a public key when you put the seed,
Yep.
but some people were using the wrong public key and they still seem to synchronize. Is that checked or is that just more a hint?
Should be being checked. If it's not being checked, then it's a bug.
Because when the Xenon phase started, some people were using, because the public key changed.
Yeah.
Some people were still using the old public key with the new node, and they still managed to get synchronized apparently. So, and I haven't looked at it in more detail. It's like that's peculiar, but.
Well, the seed node can, if the seed node handshakes with you, it can rekey. So as long as it's using the right key. Yeah, if you're given a stale public key, and you proceed to, yeah, I think there is a way for that key for that to work. I just need to think more about it though. But
That seemed to be the case in practice, and I wasn't expecting it to work, but
yeah,
apparently.
I can look more into it.
Because apparently that's the first node you talk to anyway, though. So you're bound to be able to. You don't have any other people, so you're probably going to re-authenticate. Maybe, I don't know.
Yeah, I can look into it. It should be being used. I agree. Can you open an issue for that?
Yeah, I was going to, but I never. I didn't spend enough time. I wanted to just at least try to see if, for myself whether I was doing it or not, because that was just other people doing that. Although I think we can trust not necessarily one person, but multiple people doing that. So yeah, I can open an issue.
All right. Anything else for discussion?
Yeah, there's one weird thing because I still looking in from many different aspects and why we have so many forks even with fewer nodes. I seem to notice that around the time there were multiple transactions, there were more likely to be forks, because when you run the stacks node with the TX log feature, it Stacksdump can show you how many transactions there are per node. So I started looking into it yesterday, and actually I found another thing that was really weird, because I started looking, and when I received the anchor block to be pre-processed, And just before the many transaction, the block before that, were there two transactions, the Coinbase and a 500 STX, probably a faucet. By the time the block, it takes 470 seconds for the block to, between the time it's received and the time you see the accepted message. That's 4.5 minutes.
Yep. Is this on Xenon?
That's on Xenon. That was just a few days ago, and I'm so this is not right. This is and right after that there's a bunch of forks happening, and that block already got, that anchor block was already late getting to my node, because I had received the one previous to that, which had like 50 plus transaction, but that block gets processed and accepted in 20 seconds. And right after that, I get that second block, the previous block, the one before that, and that 4.5 minutes before it gets accepted by the time, after the time it get received. And I think I could probably find that pattern maybe other times. I haven't looked at what other transactions are in the next block, but the fact that 4.5 minutes, that's not right. And my machine is more powerful than most because it's a Xeon 8 core. So that's not as.
We would need a lot more data than that to figure out.
Oh, yeah, no, I'm just saying that there's something. So I'm going to look into it more today and see, hopefully, if I can find more of that stuff or what else is going on. I don't know. But it's just something I discovered last night. It was like, oh, something's not right.
Yeah, I'd be curious to know why, because the block
Oh, yeah.
is nearly that long to process.
Because like there's two transactions, so that's really not, that shouldn't be that difficult.
It's not the block, it's something else. I guarantee it.
Oh yeah, no, I don't know what else is going on, but and that's right around the fork, and I'm probably going to try to see if I find other blocks that behave similarly. But the fact that that block got late already is interesting too as well.
I wouldn't be surprised if it's part of the pruning, honestly. Like network, the inventory synchronization can take a long time, unfortunately, because it does some IO heavy work as well, like storing neighbor information and being kind of cavalier about how many neighbors will try to handshake with at once. So
but the thing I was using to get the block received was just the pre-process. Is that
if there are other blocks though that are, you know, intermittent ancestors, and your node hasn't had a chance to go find other nodes that have those intermittent ancestors, then the block will sit there not being processed.
No, that was the first time I ever hear about that anchor block, which is already late because I already got the one from the next burn block. I got that anchor block a few seconds after finishing processing the next block, the next anchor block. So I got block 1, I get 3, and then suddenly I got 2, and number 2 is the one that takes forever to process and accept. So that number 2 was already late getting to my node.
Yeah, that can happen already. I mean, like if your node doesn't get a block broadcasted to it, it will eventually try to ask a neighbor for it because it knows it's missing.
Well, I think it was kept asking, but the fact that nobody would give it to me is probably done. And I think I'm going to see the same pattern for every time there's a fork, where there's a block that got late. That's why we got so many miners actually anchoring their block on the previous one, not 2 blocks before or late or even further. And
Do you have the block hash?
Yeah.
It'd be interesting to see how other miners. I have the burn block heights. Hang on. That's the block hash. Yeah, I've got everything you probably want. So that's, let me paste that. And the hashes are this. That's the block that took 4.5 minutes to process. It'd be interesting to see other nodes and see whether they had the same hiccup with it.
Can you put this into an issue so we can track it there?
I'll look and try to find other ones because I'm pretty my guess is that I'll find more similar issues, and then we can maybe see a pattern.
Yeah, I think that that's also the first block in a reward cycle.
Mm-hmm.
Or is
Um,
in X4
So-
that's the first block in the reward cycle? Because in X3 there was there was 15 and 65.
I see. I think in X4 it's just on the tens. So that's 0. So 1 and
Yeah, I haven't actually tried to figure that out, but I should have. Oh no, I'm filtering. Oh, so that would be interesting if that's the case. Yeah, block 0 was 2511. No, so that's not. Yeah, 60. No, it's 50, right? It's 40 plus 10 on testnet. So that's not.
Maybe let's continue the conversation on Discord
Yeah.
since we're at time here. I'm sure
I'm sorry.
everyone. All right.
Ready? Stop recording.
Cool.